Hello guys, welcome back to our channel Mathemagix JEE. Today we are going to discuss a question that was asked in subjective paper of ISI in 2021. So as usual, you should give this question a try before seeing the solution. And if you are unable to solve it by your own, then don't worry because I am there to help you with the solution. Learn from my solution, and as this question contains an important concept from the perspective of JEE, so try to learn from my solution. In this question, we are given that Px is a polynomial of this form where x belongs to the set of real numbers, and Px is an even function for all x belongs to R, and Pk is a k square for k equal to 0, 1, 2, 3, so on up to 9, and we are to find the value of limit extending to 0 p of x divided by sine square x. Now we see here, if we expand this sigma notation, we get Px is equal to x to the power 20 plus a0 plus a1x plus a2x square plus so on up to a19 x to the power 19. Now Px is a polynomial of degree 20. So if we use this fact here, Px is an even polynomial, then we can surely say that the coefficients of all the odd degree terms, odd powers of x, will be 0. So a1x this term and a3x cube and a19 x19 terms like this will all be 0. So we can say that a1 is equal to a3 equal to a5 equal to a7 and so on up to a19. All these odd coefficients will be 0. Now basically we are left with the expression for Px, which is x to the power 20 plus a0 plus a2x square and so on up to a18 x to the power 18. Now we have a0, a2, a4 and so on up to a18. Total 10 unknowns to be solved here, and we are given this information: p of k equal to k square for k equal to 0, 1, 2, 3 and so on up to 9. So we are given the value of Px for x equal to this. So total 10 equations we will get from this information. Now if we try to form all the equations and then solve them simultaneously, then it will be a quite laborious task. So we apply a different method here. Like we assume a function h of x which is equal to p of x minus x square. Now we can observe that h of minus x is same as p of minus x minus x square, and p of minus x is equal to p of x, so it will be same as the value of hx. So hx is an even function. Now as hx is an even function, we can use the property of even functions, which is x equal to a is a root of h of x. If this happens, then x equal to minus a will also be a root. So if we try to find hx, we see that hx is a polynomial whose roots are these values, that is x equal to 0, 1, 2, 3, 4 and so on up to 9. That means x equal to 0, then x equal to minus 1, then x equal to minus 2, minus 3, minus 4 and so on up to minus 9 will also be the other roots of hx. That means hx is a polynomial whose roots are 0, plus minus 1, plus minus 2, plus minus 3, and so on up to plus minus 9. Now, how many values of x are there? So there are total of here 9 into 2, 18 values, and then this value. So there are total 19 roots here of hx. But we know that hx is a polynomial of degree 20. So there must be another real root of hx, and also we can say that hx is a monic polynomial, as we define hx as p of x minus x square, and p of x is itself a monic polynomial. A monic polynomial is a polynomial equation the coefficient of whose highest degree term is 1. So that means hx is also a monic polynomial. So the leading coefficient, that is the coefficient of the highest degree term of hx, must be 1. So we can write hx as something like x plus c times the factors of hx. That means x times x minus 1 into x plus 1, that is x square minus 1, then x square minus 4, then similarly so on up to x square minus 81. Now we see that h of x, if we expand this whole expression about this, then it becomes x square times x square minus 1, x square minus 4, and so on up to x square minus 81, plus c times x into x square minus 1, x square minus 4, x square minus 9, and so on up to x square minus 81. So this is basically our hx, and hx is what? Px minus x square. So p of x is equal to x square plus x square into x square minus 1 into x square minus 4, and so on up to x square minus 81, plus c times x into x square minus 1 times x square minus 4 times x square minus 9, and so on up to x square minus 81. Now if we use the information given to us, p of x is same as p of minus x, that is px is an even function. So if we use that fact here, we see this term does not create any problem, this term will also not create any problem, but this term will create problem, as these are all even terms. If we replace minus x here, then these terms will be unchanged, but if we replace minus x here, this sign will be altered. So as p of x is equal to p of minus x for all x belongs to real number, then this coefficient c must be equal to 0. That means p of x, as we find it becomes x square plus x square times x square minus 1 times x square minus 4 and so on up to x square minus 81. This is our polynomial px. So if we apply the given limit here, limit extending to 0 p of x by sine square x, then we are left with limit extending to 0 p of x is x square, we take common, then 1 plus this multiplication here, and then in the denominator sine square x. Now we see that limit extending to 0, this term will be 1, and if we put x equal to 0 here, as we approach x towards 0, so this term will become minus 1 times minus 4 times minus 9 times so on up to minus 81. So this becomes 1 into, inside the bracket, minus 1 into minus 4 minus 9 and so on up to minus 81. Now we have to find this value. What is this? this can be written as there are total 9 terms, so odd terms. That means if we multiply -1 odd times, then a overall minus sign will be there. So we can take here as minus, then inside this bracket 1 into 4 into 9 into so on up to 81, and this will be 1 minus, and here it can be written as 1 square times 2 square times 3 square times so on up to 9 square, and this can be written as 1 into 2 into 3 into 4 into so on up to 9 and whole square of this term. 1 into 2 into 3 into 4 into and so on up to 9. That means 9 factorial and then whole square of that. So limit x tends to 0, p of x divided by sine square x is equal to this. So this is our required answer.